Hydrogen. Hydrogen is one of the simplest elements we are having in the periodic table. It is the first element, which is actually why we call it first, because its atomic number is 1. We know that hydrogen is very much related to our day-to-day life in many ways. From being part of the organic compounds, being one of the most important constituents of organic compound, it is also being widely used as a fuel nowadays. In fact, we nowadays see our future of fuel, or the biggest problem of the energy crisis, in the form of the hydrogen, because it can be used as a very efficient and very economical fuel. So nowadays we are relying heavily on hydrogen. That is why that makes this hydrogen element very, very special to us. Now, hydrogen's first thing we need to understand is its position in the periodic table. Now, why we are discussing this position of hydrogen in the periodic table? Because in the modern periodic table, as we have done in the case of periodic properties, the position of hydrogen is not fixed. The period assigned to this is, of course, is first, but as such, if we are talking about group number, there is no group number assigned. If you remember the periodic table, almost of the shape of this one, remember we places hydrogen here separately. Why is it so? Let me brief it to you. The reason is because we know, most of us, we assume that it is actually lithium, sodium, potassium, rubidium, cesium. This we know, and francium. We never takes francium because being radioactive. Most of us, we think that hydrogen belongs to group 1 here. But remember, even if you see those periodic tables, you will find that it is not actually directly linked with this block. It is being placed separately. Now, in some properties, it resembles with these alkalis. Now, what are those properties? Like, yes, it can lose electron. This hydrogen atom can lose electron and can form proton. Yes, it also forms what? Ionic compounds. And yes, it has 1s1 electrons, which resembles the ns1 configuration of group 1 elements. And that is how, because of these properties, we say that yes, it resembles with alkalis. But yes, there are many other ways, many other properties on the basis of which we can say that yes, it differs from alkalis. Like, let me tell you. First, it forms a diatomic molecule, which no other alkali forms. Its ionization energy first is very high. Whereas if you remember, the first ionization energy of lithium is only 520 kilojoules per mole. Whereas its first ionization energy of hydrogen is 1312. This we have done in the atomic structure chapter also, 1312 kilojoule per mole. On the other hand, we know that if we compare it with because of these reasons, we say that it doesn't belong to group 1, rather it belongs to group 17 halogens. We need to know the ionization energy of fluorine also, which is 1680 kilojoules per mole. That's very high, and what we find is this energy and this energy, they are comparable. So that is how there is one more important thing which separates this hydrogen from the alkalis. After losing one electron, the size of this proton formed is very small. Its size is of the range of 1.5 into 10 to the power minus 3 picometer. We know usually cations are of the size of 50 to 200 picometer, but that's very small. And that is why we say that it doesn't belong to any of these alkalis. It's not belonging to any of the alkalis. This is its very unique property. Now let us see how we cannot even say that it resembles the halogens. We know that here we have group 17, which includes fluorine, chlorine, bromine and iodine. Now these, of course, we say sometimes that it resembles with halogens. Why? Because we know that it can accept electron and can form what, hydridan, like these all does. It is only short of one electron to get noble gas configuration, like they used to get these these halogens. Yes, this is again one of the properties. There is one more important thing which we believe that, like these all exist as F2Cl2 Br2I2, hydrogen also exists as hydrogen molecule. It has what, non-metallic properties. It's a gas. Fluorine is a gas, chlorine is a gas, bromine liquids, iodine is the only one which is solid. So it's a non-metallic character. So all these makes it what, resembling with halogens. But yes, there are points which makes it what differ from halogens also. Like one I told you that yes, the size of this H plus is very small. We know that anions always are bigger in size. Its size is very, very small, of the range of 10 to the power minus 1.5 into 10 to the power minus 3 picometer. That's very small. And moreover, what we find is it shows metallic character at a very low temperature. So these are certain things which actually separate the hydrogen from halogens also. We cannot place it along with the halogens. So that is why its position is not fixed. The group number is 1, of course, but it is placed separately here. It's not belonging to any particular period. Is fixed, the first period, the group number is not given. Now let us see this dihydrogen's occurrence. See, dihydrogen is one of the most abundant element of the universe. In fact, 70% of my mass of the universe is made up of hydrogen. It is again one of the most abundant element in the solar system. And when we move to our own Earth atmosphere, what we find is Earth's atmosphere is only 0.15% by mass is hydrogen. As because it is very light it's one of the lightest element we are having, so it moves up, and that is why Earth's atmosphere is only 0.15% by mass is having hydrogen. Whereas in combined state it exists in different forms in the Earth crust, and almost about 15.4% of Earth's crust is hydrogen. It exists in the form of organic compounds along with the carbon and other elements. It exists in the form of what, acids, alkalis. It exists in the form of hydrides and all the different compounds on the Earth's crust, and that total constitutes about 15.4% of hydrogen. Now, after understanding the occurrence of hydrogen, let us move to the isotopes of hydrogen. Hydrogen basically is having 3 isotopes. One is called protium, deuterium, and the third one is called tritium. Now, protium is the predominantly most abundant isotope of hydrogen. It is having only what, 1 proton and no neutron. That is why its mass is only 1. Now, deuterium, we also indicate it by symbol D, or we write it 1H2. 1 is the atomic number, 2 is the atomic mass. It contains, yes, proton 1 and neutrons 1. And it is actually the second most element abundant out of the 3 isotope of the hydrogen, and its percentage abundance is only about 0.0156% of the total normal hydrogen, and exists mainly in the form of HD. Then the last one is tritium. Tritium we also give represented by a symbol T or 1H3. It contains what, 2 neutrons, and there is proton is only 1. That is why the total mass is 3. Now this tritium is very, very rare. Only one atom per 10 to the power 18 atoms of protium are of what? Tritium. This tritium atom is radioactive because its NP ratio is 2 and it emits a beta particles of low energies. Its half-life is 12.33 years, and what basically we doesn't know much about the tritium, but yet the protium and deuterium, they differs in their properties to some extent. But physical properties, yes, they are very much different. Like melting point, boiling point, and densities of deuterium are higher than the normal protium. And what we find is that yes, their bond enthalpies are also different. Bond enthalpies of deuterium is a little bit higher than the normal protium. And what we find is the reaction if we are having the pure hydrogens also differ to some extent. But yes, this is how we have the isotopes of hydrogen and their relative percentage abundance. Preparation of dihydrogen. Let us see the preparation methods. First, we will see the lab methods. The first lab method includes reacting the zinc with dilute HCl. This forms zinc chloride and hydrogen gas is released, which can be collected by downward displacement of water. The second method is again by reacting zinc with alkalis like NaOH. This results in the formation of sodium zincate. And it releases hydrogen, which can be again collected by downward displacement of water. So this is called sodium zincate. Now let us discuss the commercial methods or industrial methods of preparing hydrogen. Now commercial methods include, the first one is by the normal electrolysis of water. We put small amount of dilute sulfuric acid to make it water as an electrolyte. We know that water on electrolysis breaks down into hydrogen and oxygen. We can easily get hydrogen as one of the products, and this hydrogen gas we use platinum electrodes. Inert electrodes are used, and this hydrogen gas is actually being produced as due to the reduction of water. So this takes place at cathode. So this is how we can get one of the industrial method of getting hydrogen is by the electrolysis of water. Yes, we can also get hydrogen by electrolysis of barium hydroxide solution, which gives us using nickel electrodes. We get hydrogen with a very high percentage purity. The third method of preparing dihydrogen is by electrolysis of brine solution, aqueous NaCl. We know that aqueous NaCl breaks down into what? Na plus and Cl minus. We know the reaction sodium try to accept electron but doesn't happen. This happens at cathode because its electrode, the reduction potential, the tendency to accept is far less than the water. Water accepts electron and get reduced to H2 plus and OH minus. So this becomes like this, and this is how we get hydrogen. In this, remember, at anode we get chlorine, which gets oxidized to form chlorine gas as the product at anode. and it's not oxygen. So by aqueous solution of NaCl or by brine solutions electrolysis, we can also get hydrogen. The next method of preparing, the commercial method of preparing the hydrogen is by the action of steam on hydrocarbons. When steam is actually being passed through any hydrocarbon or is reacted with any hydrocarbon, we get water gas, carbon monoxide and hydrogen. Now this water gas is used in the preparation of a number of compounds like methanol, formaldehyde and many other compounds. That's why it's called synthesis gas or syngas. So from this here we can easily get hydrogen. We need to know this also, that yes, we can get this water gas from coal also by reacting it or passing steam over it, and this results in the formation of this water gas, and this reaction is also called coal gasification. Now we can separate the hydrogen from this water gas. How? By making this carbon monoxide of this to combine with the steam, in which what we find is it gets oxidized to CO2 and water gets reduced to hydrogen, and this is how we can easily separate out hydrogen from the water gas. Now let us see the physical properties of dihydrogen, and we will first see the physical properties. See, it's a colorless, odorless, tasteless, highly combustible gas. It is insoluble in water because it's completely is non-polar in nature, and it is much lighter in density than air. Now these are its main physical properties. Now in chemical properties, what we can say is it is almost inert at room temperature. The reason is because of very high bond enthalpy. See, in fact, one must understand this. It's having the highest bond dissociation energy among any diatomic molecule of any other element. Its bond enthalpy is 435.8 kilojoules per mole, which is very high. That is why it breaks down into atomic hydrogens at a very high temperature, around 2000 Kelvin, or under the influence of UV light or electric arc only. Another important thing which about the hydrogen is that all its chemical properties mainly depends upon its bond enthalpy. Now that is why its reactions usually takes place at a high temperature. What we need to know is that it reacts, whatever the chemical properties it shows, it shows only by three ways, either by what? Losing electron, or by gaining electron to form H minus, or by the sharing of electron. Now let us see its chemical properties. Let us see first with halogens. Hydrogen combines with halogens to form HX hydrogen halides, hydrohalic acids, hydrochloric acid, hydrobromic acids, hydrofluoric acids, hydroiodic acids. Now these what you need to know is with fluorine, even it reacts even in dark, and with iodine actually you have to use catalyst. Catalyst is to be used. Otherwise this reaction takes place easily on heating. Then let us move to oxygen. With oxygen, hydrogen combines with oxygen at around 1000 degrees Celsius to form water. Now this reaction is highly exothermic, and a lot of energy is being released, about 285.9 kilojoules per mole of energy is being released. Now let us see how it reacts with nitrogen. We know the process is called Haber's process, in which it results in the formation of what? Ammonia. This again is an exothermic process in which 92.6 kilojoules of energy is being released. This hydrogen reacts with reactive metals, all to form what? Metal hydrides, which are ionic in nature. I'm talking about mainly alkalis to form metal hydrides, ionic in nature. You make it twice, make it twice. Now, let us see its redox reactions. See, hydrogen can easily reduce the metals which are lesser reactive than iron, and itself gets oxidized, like it reduces palladium to 2 plus to palladium and itself gets oxidized. Even if we have any metal in the form of its oxide, yes, it can combine with them like this and can reduce them to metal and itself forms water. So in that way, it easily shows redox reactions with different metals which are less reactive than iron. Another important thing about this is its reaction with hydrocarbons, which you will be doing later on in the organic part, that yes, it is used for hydrogenation. We can reduce any alkene or alkyne by reacting it to convert it into what? Alkane. The same is being used to convert vegetable oil to vanaspati ghee. We add hydrogen in presence of rancy-nickel. Now, it also being used in hydroformylation of alkenes. What does it mean is, when any alkene like this one, or let me take a smaller one to make it more clear, like ethene is reacted with water gas, it forms first an aldehyde, which on further reduction results in the formation of alcohol. So this is how we can use it to form what? Aldehydes, or we can further reduce them to the alcohols. So these are the properties we have of hydrogen. Now let us discuss the uses of hydrogen. See, its most important use is in the synthesis of ammonia by Haber's process, which is being widely used in the preparation of many other compounds and fertilizers. Its another very important use is in the making of vanaspati fat or ghee from vegetable oils, which is also called saturation of the unsaturated oils. It is also being used in the preparation of many organic compounds, like one I have given, that with water gas under catalytic reaction, it forms methanol, which can be used to prepare what? Formaldehyde and many other organic compounds. It is used to prepare, remember, metal hydrides, and it is another one way of storing hydrogen, like hydrolyth vagara, and other compounds, etc. Then it is being used in the preparation of very important mineral acid, HCl, hydrochloric acid, which is being very widely used not only as a lab reagent, but as well as it has a lot of industrial uses. Then it is used in redox reaction in converting metal oxides to metal, because that's the byproducts is only water. So that's again is a very useful reaction. And you need to know this, that it is used in making what? Oxyhydrogen torches, and therefore they are used in what? Welding purpose also. That's again that is very important, because we all know about this. And then it is again is one of the very clean rocket fuel we uses in the rocket as a rocket propellant. And we should not forget that we are nowadays using hydrogen as a fuel cell. Which is not only used in rockets or in which are in the space shuttles. It is also has been incorporated into automobiles. So these are the various uses we have of hydrogen.